Hello, my name is Franklin Castillo. This is session 2 of our lecture series on ASP.NET Core MVC. Today we'll be discussing applying architectural principles and dependency injection. In this lecture, we're going to be discussing the importance of 8 architectural principles that we'll be using for the design and creation of our web applications. These are separation of concerns, encapsulation, dependency inversion, explicit dependencies, single responsibility, the concept of don't repeat yourself, otherwise known as DRY, persistence ignorance, and bounded context. So by the end of this lecture, you'll be able to apply these principles in order to make your applications modular, more testable, and stable. Along the way, we're going to be implementing several tutorials that will apply these principles, as well as specifically the concept of dependency injection to the project that we began in session 1, where we developed the beginnings of a movie database. When we talk about architectural principles and software, what we really mean is how do we design applications so that they are easier to understand, to fix, and to expand over time. Writing code that works is really just the beginning of this process. If that code becomes a tangled mess, then every small change will risk breaking something else. That's why maintainability is at the center of good software architecture. A maintainable application is one that is organized into smaller pieces or components where each piece has a clear role. Think of these components like workers on a team. Each one knows their job, but they don't constantly step on each other's toes. Instead, they talk to each other through well-defined rules, which in programming we call interfaces. Sometimes that communication is even handled through messaging system, which lets parts of the application exchange information without being directly tied together. Why is this important? If components are tightly bound to one another, then changing one piece forces you to change many others, and the application quickly becomes fragile. By keeping components separate, you make it possible to upgrade or even replace parts of that system without rewriting everything else. This approach not only keeps the code base cleaner, but it also lowers the cost and risk of future development. These principles are intended to guide us as we move from writing small programs into building larger and more complex applications. One of the most important principles in software design is called separation of concerns. The idea is that we want to keep different responsibilities in our application apart from one another. A concern, quote unquote, is just a specific kind of work that the software has to do. For example, imagine that you're building an application that decides which items are important enough to highlight to the user and then format those items so that they stand out visually. You can see that these are two different concerns. One involves decision making or business logic, while the other is about presentation or formatting. If you mix these two together in the same code, it becomes harder to understand, to test, and then to change later on. Architecturally, separation of concerns often means splitting applications into layers. A common pattern is to keep the core business rules in one place, the user interface in another, and the infrastructure such as databases or external services in yet another layer. By organizing our code this way, we can create boundaries between these different layers. Business rules don't need to know how data is stored or how the user sees it. They just need to focus on the rules themselves. This approach pays off when the application grows over time. If you ever need to change how the interface looks, you don't risk breaking the rules that determine what data is shown. Likewise, you can test the business logic by itself without worrying about database design or screens. This separation makes the whole system easier to evolve and extend, as well as maintain over time, which is why it is such an important principle. Encapsulation is another principle that helps keep software maintainable and flexible. At its core, encapsulation means protecting the inner details of a component so that other parts of the program only interact with it in a controlled way. As long as a component continues to honor the contract that it exposes to the outside world, which is once again what we refer to as its interface, its internal implementation can change without breaking the rest of the application. This makes it possible to swap out one piece for another as long as both agree on the same interface. In object-oriented programming, you see this through the use of classes. A class will usually hide its internal data by making it private and will only expose controlled ways to interact with that data, such as methods or property setters. For example, if you want to update a balance in a bank account, you might have a class that does this for you, and to do this, you don't need to reach in and change the actual number. Instead, you can call a function like deposit or withdraw, which makes sure that the different rules in the system are followed. By keeping direct access hidden, you reduce the chance of invalid or inconsistent states in your application. Encapsulation also scales up beyond classes to entire components and layers of an application. Each layer should provide clear entry points and avoid exposing its internal state. One major threat to encapsulation is what is known as mutable global state, that is, variables that can be changed anywhere. If one part of the program alters a global value, another part can't rely on it to stay the same. That's why careful use of scope and disciplined access to shared data are so important in designing reliable modular systems. Dependency inversion is about changing the direction of how parts of a program depend on one another. In most applications, dependencies are direct. If class A calls class B and class B calls class C, then at compile time A depends on B and B depends on C. This is shown in the direct dependency graph. The flow of execution at runtime matches a structure, which means higher level logic ends up tied directly to lower level details. The problem with this is that it couples higher level parts of the system to lower level implementations. If class C changes, it can ripple upward, forcing class B and class A to change also. That makes the application harder to maintain and to test later on. The dependency inversion principle solves this by introducing abstractions, which are usually made in the form of interfaces, and these sit between the higher level and lower level classes. So instead of class A depending directly on class B, class A depends on an interface, and class B agrees to implement that interface. At compile time, the dependency flows towards the abstraction, not the implementation. At runtime, the behavior is the same. A still calls B, and B may still call C, but the compile time structure is inverted. This inversion makes the system far more flexible. You can replace class B with another implementation without touching class A, and as long as the new implementation still follows the same interface, this arrangement will work. This design is a cornerstone of what is known as loosely coupled applications, and it's what makes practices like dependency injection possible for us to use. The explicit dependencies principle is about being direct and explicit in the way that we design classes and methods. If a class or method needs another object in order to work correctly, it should state that requirement up front rather than hiding it. This means that dependencies should be passed in explicitly, usually through the constructor or as parameters to a method. Think of it this way. When you look at the constructor of a class, you should be able to see exactly what that class needs in order to be in a valid state. If a constructor doesn't list these requirements, but the class secretly depends on some global object or configuration, then it is misleading. The class looks like it can work on its own, but in reality, it will break unless the hidden dependency is present. That kind of design creates surprises and makes the code much harder to use and to test. By following the explicit dependencies principle, you create code that is transparent and trustworthy, and anyone using your class knows that as long as they provide the required inputs through the constructor or other method parameters, the class will function correctly. This makes your code more self-documenting because the contract between a class and its collaborators is clear. It also makes testing easier since you can provide substitutes or mock versions of dependencies without having to set up complicated or hidden infrastructure. In short, explicit dependencies keep your code honest and reliable as you develop it. The single responsibility principle tells us that every object should only do one thing and it should only have one reason to change. If a class is handling two or three different responsibilities, then any change to one responsibility risks breaking the others. This makes the system harder to maintain and less predictable. By keeping each class focused on a single responsibility, you get code that is easier to understand, test, and to reuse. For example, imagine you have a class that both calculates payroll and sends email to employees. These, as you can see, are two very different responsibilities. So if the rules for payroll change, you shouldn't risk breaking the email feature. Instead, it's better to separate those into two classes, one for payroll and one for notifications. That way, each class can evolve on its own without interfering with the other. This principle isn't limited to classes. At an architectural level, it applies to layers within an application. The user interface should only deal with presentation, the infrastructure should handle data access, and the application core should contain the business logic. Each layer has its own responsibility, which makes the system more modular. When taken to a larger scale, the principle even leads to microservices. A microservice should have a single responsibility, just like a class. If the system needs new behavior, the safer approach is to add another service rather than overloading an existing one. This approach keeps systems flexible and easier to maintain as they grow. The don't repeat yourself principle, or DRY, is all about reducing duplication in your code. The danger with repeating the same logic in multiple places is that eventually requirements will change. When that happens, every copy of the duplicated logic has to be updated. In practice, it's easy to miss one and the system ends up behaving inconsistently. These kinds of bugs are frustrating because they often hide in plain sight. The solution is to put the shared logic into a single place, such as a method, class, or module, and make that the one authority for that behavior. Any other part of the application that needs that particular behavior should call the shared construct instead of copying the code. This way, if you ever need to update the behavior, you only need to do it once. That makes the system more reliable, easier to maintain, and easier to understand. However, it's important not to force everything into a single definition just because it looks repetitive. Sometimes repetition is only coincidental. For example, if two constants both happen to have the value 5 but represent different concepts, they should stay separate. Collapsing them into one constant would make the code less clear because now two different ideas are being tied to the same abstraction. The key is to eliminate true duplication while still respecting the conceptual meaning of different parts of the program. Persistence ignorance is the principle that your business objects should not have to know or care how they are stored. In .NET, these are often called POCOs, or plain old CLR objects. They're just regular classes that focus on representing business rules and data without being tied to a specific database or persistence framework. The advantage of this approach is flexibility. If your business objects are persistence ignorant, you can change how they are stored without rewriting your entire application. For instance, you might start with a relational database, then later add a Redis cache or even switch to a cloud database like Azure Cosmos DB. If your business objects are free of persistence concerns, you can make these changes with much less risk and effort. Violating persistence ignorance usually means forcing your classes to adopt features required by the persistence layer. Examples of this include having to inherit from a certain base class, implement a persistence-specific interface, or add attributes just to satisfy the database. Sometimes persistence frameworks require odd constraints like parameterless constructors or virtual properties. These requirements couple your business objects directly to the persistence technology, which is not good. The more your business objects depend on persistence-specific rules, the harder it becomes to evolve your application. If you ever want to swap technologies, you'll find those requirements baked into the core of your code. By keeping your business model persistence ignorant, you preserve the freedom to adapt your data and its access to other systems as they change and grow over time. A bounded context is a way to manage complexity by drawing clear boundaries around parts of a system. The idea comes from domain-driven design, which focuses on modeling software around the business domain that it represents. A bounded context defines a space where certain concepts, rules, and behaviors are consistent. Inside that boundary, terms and models have a specific meaning, but outside it, those same terms might mean something different. Think of it like different departments in a company. The word account, in that sense, might mean something very different in accounting than it does in customer service. By separating these domains into bounded contexts, each can evolve independently without causing confusion or conflicts with the others. In practice, this often means that each bounded context manages its own persistence, usually through its own database. Sharing a single database across multiple applications shares hidden dependencies and makes it harder to change things without breaking other parts of the system. Instead, bounded contexts communicate through well-defined programmatic interfaces such as APIs or events. This keeps boundaries intact while still allowing contexts to work together when needed. Bounded contexts line up closely with microservices. Each microservice is its own bounded context with its own model and its own persistence and rules. If the system needs to grow, you add another bounded context rather than stretching an existing one to cover more ground. This approach keeps the system modular, clearer to understand, and easier to maintain over time. In the first session, we built the MVC movie application. We used the scaffolder to set up the entity framework for us and plugged in the database context into the controller automatically. Now let's take a moment to observe how the framework goes about doing this. This is going to introduce us to the concept of dependency injection. Normally, if we need to create another class where one class needs to implement another, we simply would use the keyword new. And generally, this is how we would always do it in a object-oriented programming environment. However, this does cause some issues. First, it couples the class that we are implementing to our implementation. And if we want to replace it later, or if we want to test our class without that particular dependency, then we are stuck. ASP.NET Core solves this for us by managing the objects for us through the use of dependency injection containers. So instead of controllers creating their own objects, the framework asks us to declare what we need. It provides those objects for us and then facilitates the execution. So this is the principle behind dependency injection. The container inside the ASP.NET Core framework is responsible for constructing objects, wiring up their dependencies, and of disposing of them when they are no longer needed. We register services in program.cs, and when the controller runs, the runtime looks at the constructor parameters, matches them by type, and supplies the right objects. The dependency injection container therefore does all the work for us. For each parameter, the container creates or reuses an instance based on the lifetime that we register. So there are different types of service lifetimes. The first is transient. So when we say transient, what we mean is that the framework will give us a brand new instance every single time that we ask for it, even inside the same request. Next, we have scoped instances. And during a scoped lifetime, this means that we get one instance for the whole HTTP request. So everything in that request, your controller and any services, they all share the same copy. And lastly, we have the singleton lifetime, and this means that the framework will make one instance when the application starts. And that same instance, in fact, is shared everywhere up until the point that the application shuts down. One example of this is DB context, which is scoped to the default lifetime, and it will fit in how we usually work with data per request. The benefit of this is that we can change implementations in one place without touching controllers, and in testing we can pass it, say, a fake service instead of having to spin up a database. So with that said, let's return to our MVC movie application, and we're going to add some enhancements using dependency injection. Okay, we're going to begin by creating an interface. So if you'll remember from the principles that we discussed, one of the principles is dependency inversion. The point here is that, and the objective of what we are going to be doing here is that we want to decouple the way that we are currently using the MVC movie context inside of our controller. Right now, we're doing a lot of query generation for different objects in our database, and we don't want to do that. Remember that we want our controllers and different parts of our program to be agnostic to the inner workings of the objects on which they rely. So instead of us doing all this and checking whether the movie exists, such as here. So if the movie is null, then we are going to take some remedial action. Instead of us having to worry about all that, we're going to aggregate all of that logic inside of a couple of service classes. And in fact, that is exactly what we're going to call this next folder. So we're going to right click and we're going to add a new folder called services. The first file that we are going to create is going to be called iMovie service, and this is going to have the interface on which we're going to be relying for all of our different movie operations. So I'll go iMovie service.cs, and for now, yes, so this is in the MVC services namespace. This is fine. And now what I want to do here is that I don't want this to be a class. I'm going to have this be an interface. Next, I am going to add some of the members of this interface, on which we're going to be relying inside of our controller to perform the different operations. So we're going to start with the operation that is going to get us an enumeration of all of the movies in our database. So this is going to be a task, and we're going to call this task IEnumerable and then movie. And this is going to be called get all async. Okay, so Actually, and one of the things that we want to do is we're going to be relying on several libraries. The first is going to be using system collections generic, so that's how we're able to leverage the IEnumerable um, data type or object. And then we're going to be using system threading tasks. And this is how we're going to be using asynchronous methods that um, wait for a response through the await statement. So, if you don't understand what that means yet, that's fine. We're going to be getting there very briefly. So the next member that we're going to be adding is going to be called getById async. So this is going to return a single movie, task movie, and for this we're going to be using the null conditional operator because it is possible that this object, if we use a particular ID, it is possible that this object, this movie, does not exist. So we want to be able to handle any potential null values. So we're going to say get by ID async, and then we're gonna pass an integer for the ID. Okay, next is going to be a task, and here we're going to add a movie. So we are not going to be returning anything. We're just adding a movie to the database. So this is just going to be called add async, and we're going to pass a movie to it. Next, we're going to say we're going to have an update async, and this is we're going to pass the movie, and essentially it's going to overwrite any existing entries in our database. And this is going to be update async, and for this one, once again, we're going to be passing a movie object. Lastly, we're going to be creating the delete async method. And this is just going to receive the ID of the movie that we wish to delete. Okay, so our interface is created. Now we are going to be implementing the actual class that is going to be interacting with our database. And this, we're going to have it in services as well. And we're going to go to right click, we're going to add and new item, we're going to add a class, and this is going to be called movie service. Okay, so this is the function, or rather this is the class that is actually going to be interacting with the database, and everything that we do with this is going to occur through our interface class, or through our interface. So here I'm going to be relying on several libraries. I'm going to using Microsoft Entity Framework Core, and that's just because we're relying on the database. We're using the database, so the Entity Framework Core is required. And we're going to be relying on two classes that we created here. The first one is the data class, and then the models class. Okay, then from here what we're going to do is we're going to have this be a subclass of iMovie service. So this is going to extend iMovie service. So right now we haven't implemented any of these yet. I'm wondering if it'll build it, if it'll build these for us. Let's just see. So let's implement the interfaces, and this is certainly something that we can work with. We get to save some time. So, but let's just do some rearranging so that these match the order in which we created them in the interface. We have the delete async at the bottom. Everything else looks good. So before we go any further, we need to create the constructor. So this is actually going to have the MVC movie context, and that is how we're going to be connecting to our database. So we're going to say private read only MVC movie context, and this is just going to be called DB. So notice that this class is starting to take the shape of how we've implemented the MVC movie controller inside of our movies, or excuse me, how we've implemented our MVC movie context inside of our movies controller. So by relying only on the interface, we don't have to worry about these implementation details. All that can happen in the background. So let's start building that out slowly. We're going to say public, and then this is going to be called movie service, because once again it's a constructor, and this is going to take this movie context. Okay, and I think I'm just going to use a lambda operator. That works perfectly. For the next one, for the get all async, what I'm going to do is I think I'm going to use another lambda operator, and this one is going to be asynchronous. And what this means is it's going to take some time. It has to go to the database, so we cannot expect that the request is going to be fulfilled as soon as the class finishes. So instead, we have to send back a promise, which is why we have this async await dynamic. So we're going to do await, and we're going to reference the database object for our context, and we're going to say movie, and we're going to be including this method to list async. Okay. Next, we're going to move on to the get by async, and essentially here what we're doing is we're just getting the match for a movie based on their ID. So here once again we're going to use an async modifier, and we're going to await the return db movie, and we're going to say first or default async, and here we'll use movie, lowercase movie, and then we're going to say movie dot id is equal to id. So whenever we call this method get by id, it is going to go to the database and get the information for that particular ID and turn it into a movie object and return it back to us. The next one that we'll do is the get async, or excuse me, the add async. And for this one, what we're gonna do is we're going to add the movie, right? So we're passing the movie to the database. So we're going to say db movie add, and we're going to add the movie, and then we're going to call this method called save changes async. So once we execute, once we add our movie to our database, we have to ensure that changes synchronize. Next, we're going to add our update logic here. So it's going to be very similar, almost identical to the add async method, but instead of adding, we're going to update. And notice that it's not liking this, and that's because we don't have the async modifier. Lastly, we're going to build out the delete async method. So here what we're going to do is first we're going to find the movie. So here we're going to say var entity, and we're going to say await database movie find async, and we're going to pass the ID. Then if the entity is null, we're going to return, and then we're going to if this variable is not null, then we can move forward with the removal. I can say db movie remove and then entity, and then we're going to save changes to the database. We're going to commit those changes and synchronize. So that's all we need to do for our services. Now we need to register the service. We need to register these to our program.cs file. So we're going to go to program.cs, and we're going to add some lines in between these two objects. So notice we have our database, we have our method that gets the database context. From then inside here, and in fact I think I want to move this before. So add controllers with views. Actually, I think I'll leave it there. So what I'm going to do is I'm going to register our domain service, and in our case, our domain service is this movie service that is going to help us to interact with our database through from our controller to our database through our interface. So here we're going to say builder services, and we're going to add scoped, and we're going to include iMovie service and then movie service. Then we're going to bind, actually that is it. So we're building, and then we're done with this part. Now we can incorporate our interface onto our movie controller, and as we go forward, you're going to notice that a lot of the logic that we had to include in some of these tasks in these methods they're essentially going to be going away. So instead of using the context directly, as we already mentioned, we're going to use the iMovie service interface. iMovie service movies, and that is going to be the object that we're going to be using, and then we're going to say movies, and we're going to replace this context with this movie. Okay, so now that is going to have certain downstream effects throughout our code, so we'll just go one at a time and change these. So first of all, the movie, because we can guarantee that the movie is not going to be null, either because the interface the movie interface, this class here, is going to interfere on our behalf if it is not found. We can get rid of this logic where we have to check if the movie is null. So we can get rid of that, and we can also get rid of these queries where we are getting the genre information and so forth from our database. So we're going to start by creating some objects here, and we're going to say var all, and this is going to be, actually, let's see, this is going to be I enumerate movie, and for this one I'm going to go ahead and I'm going to import the collections library. Actually, it's already there. It's enumerable. IEnumerable. And here we're gonna go await movies get all async, and here we're gonna store all of the movies in our database. Next, we're gonna create another one, another IEnumerable, and this one we're going to call movies. And that for this is just going to be something that we're going to be using later on, especially for these filtering operations. And then we're going to create one called genre query, and this is going to be all, and this is going to be we're gonna select the genre. Actually, I think this is going to be a string array. So let's call this movie just to be more explicit. Okay. So this is going to be an enumeration of strings, and this is possible that this could be null. Let's see how we can handle this. So because we had defined, if we go back to our models for our genre, remember that we used the null conditional operator because we recognize that there could be some ambiguity in the genre. We accepted that genre could be null. So what we're going to do is we're just going to have this be, we're going to include the null coalescing, or rather the null conditional operator here as well. And then here we can begin adding changes to the logic when we search either by string or by genre. So for the search string, we're essentially gonna be filtering as well. We're gonna be using the where method, and here we're gonna say s for string just to save some space, and we're gonna say where title is not null, and title, so we're gonna make it uppercase, contains the search string, and what we're gonna do is we're gonna say string comparison ordinal ignore case. And basically what that's going to do is that it's going to guarantee that what gets checked in terms of this substring, right? So we want to make sure that the search string is a substring inside of our inside of the title. That is going to guarantee that there's going to be a match in one way or another, even if it's uppercase or lowercase, whatever the case may be, that match is going to occur. Okay. Next, for the movie genre filtering, we're gonna say movies where, and we're gonna use. Let's use, actually for this one, let's use movie like we did before, just to make sure, just to be explicit. And then we're gonna say where movie, where the object movie is such that the movie genre equals movie genre. So it's gonna filter on that basis. And one thing that we're going to do is we're going to add some logging, because remember that we added our logger here last time. So we just want to make sure that we're logging all of these different events. Actually, let's say info, and we're going to say searching by search string, and then we're going to use search string. And then we're going to do the same for our movie genre. Say movie genre, movie genre. Very good. Okay. So the next thing that we're going to do is we're going to get the view the view model for our page. So here, what we're going to do is we're gonna keep this object the same. It's going to be a movie genre view model. However, it's going to contain two elements here. The first is genres, and this is going to be select list genre query, and then the next one is going to be movies to list. Very good. Okay, so our index method is good to go, and we're ready to move on to our details method. So once again, all this logic, we don't really need to worry about it, and in fact, we don't need to worry that the ID might require some sort of null conditional operator, because it is an integer, and because integers are built-in data types, they are not. We don't have to worry about them being null, because they're not referencing data in memory. They're just or rather, they are not references, but rather they are data in and of themselves. So in this case, we're going to say, we're going to modify this one a bit, and instead of using all of this, we're going to say movies get by ID async, and we're going to pass the ID. We don't need to worry about the movie being whether the movie is null or not. And then we're going to say we're going to use a logger here, and let's just copy what we had here. So displaying details for movie, and then we're going to show ID as the value in our logger. So once again, you can start to see how we are sort of culling the different components inside of our controller here, and you can see that it's making things certainly more manageable in terms of what is contained. So for this one, the create is not going to change much. This is just going to say, we're just going to say, create get. Okay. For the create post, however, that one's going to look a little different. So this one, notice that we're saying that if movie state is valid, then we're going to do all this. So I think I would rather invert this logic, where if it is not valid, I'm just going to return the view, and all this other stuff, we'll just deal with that outside. So here we're going to say we're just going to use a logger one more time, and this is going to be a warning. And let's just make sure I use a warning, or I'm using the different methods correctly for my different methods here inside of my controller. So what I want to say here, or I want to put out a warning, and if the model state is not valid, I want to say create post model invalid. I think that works. Okay, so if the model is valid, it's just going to move. It's going to move on past this. So I'm going to get rid of this, and I'm going to reference underscore movies, add async, and then I'm going to pass the movie. So I'm adding I'm adding the movie. And then I'm going to say redirect to action. Okay, so that works. Okay. Next, we're going to go to edit. So this is an edit get method. So once again, I don't need to worry about int potentially being null. That's not gonna happen because ID is just going to default to 0. Next, I'm going to get rid of this this check because movie. We know that movie will be able to handle just based on the services that we've implemented. That if movie is null, that the program is going to handle that. So here we're going to say we're going to get the movie, and instead of going to a context, movie get by ID async, going to get the ID, and then we're going to return the movie, and we're going to use a logger again, and then edit get movie ID, and then we're done with our edit get method. Next, we're going to work on our edit post. So once again, we don't need to worry about this check here. And here I'm going to invert, once again, I'm going to invert the logic, which you're going to notice is going to substantially help how our logic works out. So we're going to say logger warn, and then we're going to say edit post model was invalid. Okay, I'm trying to recall what I said earlier. Model is invalid, just to be consistent. And then I'm going to return the movie view. Okay, that works. So you're going to notice that a lot of this is going to drop off as we move forward. And once again, just noticing the benefits of using an interface rather than us having to do these things like you doing database update concurrency exceptions. If for whatever reason there's an issue with the database, we don't need to have this logic. All of that is already handled for us. So what we'll do is this is gonna move up here, and then we're gonna update async. We're gonna say await movies update async movie, and that is really it. So note all of that disappears. Okay. Next, we have the delete method, the delete get method, and once again, we don't need to worry about ID being null. And for we're going to get the movie. We're going to say var movie await movies get by ID async, and we're going to get the ID number. And we can get rid of that, and we're gonna use a log event here, and we're gonna say delete get movie ID. That's perfect. And just look at that. That is much simpler than before. We don't need all this boilerplate. For this, before I go any further, I'm going to get rid of this movie exists because that we're not really using that. For the let's say for the delete confirmed, what we'll do is we're going to get the movie. Actually, no. We don't. We actually don't need to get the movie. All we need to do is do await delete async. Movies delete async for the ID. So we're essentially saying, we're saying delete this movie, and then it returns. It goes redirect to action to whatever index we're on. Okay, so so far we've reduced a great deal of our code that we had earlier, and we did this by separating the content of our by separating the different elements that from a reasonable standpoint shouldn't have been together. We don't need these, so we can get rid of those. We don't need actually, yeah, we don't need that. And let's see. So we can go ahead and save, close this one, and let's just make sure. And the thing here, that what we're gonna see is our application is just going to run the same as it did earlier. We're really not going to see any change. Everything that we did is really under the hood. So and actually, before I move forward, I want to go to seed data. So if there are any movies, this is going to get skipped. Okay, so let's run this and see if we encounter any runtime errors. We're going to go to movie app. Okay, so we got all our movies. And let's just filter. Let's filter by thriller. Perfect. By comedy. Perfect again. Okay. Any of them that have the letter A in it? Excellent. Let's say I want to delete Rio Bravo. I've never seen that one. Delete. And that works perfectly. So once again, this is not something that is going to really show up materially in the front end. However, because we did this change, this is something that is going to benefit us in the long run in terms of any changes that we might want to make to our application later on. So we're gonna see the benefits of this streamlining as we move forward. The next thing that we're going to do is that we are going to go ahead and we're going to go create the tests that we're going to need for the movie service that we just created. So to do that, we're going to be relying on the PowerShell terminal. And to get there, we're going to use View, and then we're going to click on Terminal. And in case the font size, if you find it too small, you can always go to Tools, Options, and then under Environment and Font and Colors, you can go to Terminal, and then just pick a size that suits you. Likewise, you can do the same for the output window. So I picked a font size of 18, and that allows us to see everything we need to see. So from here, what we're going to do is we are going to, the very first thing we're going to do is we're going to do a restore and a build of our application. So what we're going to do, we're going to say .NET restore, and we're gonna reference this file here, and it might be called something different in your system, but essentially this is the solution project file. This is going to be called MVC movie.csproj. And before we go any further, let's go ahead and open that file. So we can see it. And the reason we have to open it through the file menu is because you're not going to see that file in here. So let's go ahead and we're going to say file open, and then we're gonna go to File, and we're gonna go to the root folder of our solution, and we're gonna find mvcmovie.csproj. And here we're going to see several things, and some of these will be important as we move forward, but we just want to, for now, just open up that file to make sure that it's there and that is its correct name. So I made some changes, just in case I made some changes, I went ahead and I did save all. So I'm going to do restore, and my build succeeded, and then I'm gonna do that again. I'm gonna hit the up key on my keyboard, and I'm gonna say build. Okay, so once that is completed, I'll be able to move on to my next step, which is gonna be creating the unit test project and then adding it to our solution. So we're gonna say .NET new XUnit, and XUnit is the name of the library that is going to help us run these unit tests. And then we're going to create this test package, or this test project, and we're going to call it tests. And we're going to say -o for output, and we're going to say tests. We're going to run that, and we're ready to move forward. One thing that we want to make sure is that our test is, it has the right name, right? So we can open it, and you can see that there's really nothing in here right now, but I want to rename it. I want to give it another name. So I'm going to click F2 here on my keyboard. You can right click and then click rename. And we're going to call this movie service _ CRUD test. We're going to hit enter. It's going to ask us if we want to rename all the other references to that. And you'll see that the class was updated. And let's see. Over here, it should have renamed also. Let's go ahead and rename it here as well. Movie service CRUD. So we're ready to move forward, and we're going to go ahead and we're going to add the project file for the test to our solution. Now, just as we did with the project file for the solution itself, we're going to go to the test project file, and we're going to go, we're in our the test folder here, and we can see that we have this tests.csproj file. So let's go ahead and open that, and it will look similar to what we had before in terms of our MVC movie file. So the thing to look out for is that they're both in the same target framework. And we can see that they are both on .NET version 9.0, which is correct, and we're able to move forward. From here, we already ran our command to create the unit test, or rather the test project. Now we're going to add our test project to our solution. We're going to say .NET SLN for solution, add tests.csproj, and we're going to hit enter. Okay, it's going to prompt me. I'm going to hit reload. Yes, save. And we're ready to move forward. Okay, so we confirmed that our our target framework was correct, but one thing that we want to do is we want to make sure that our EF core, our entity framework core packages are installed and that they're added to our test project. So we're going to say .NET add, and we're going to reference our solution project file, MVC movie csproj, and we're going to say package Microsoft Entity Framework Core SQL Server version 9 wildcard, and we're going to hit enter. Okay, so you're going to see it's going to go out to the web to install some of these things. I'm going to hit my up arrow so I can sort of bring that command back. Now I'm going to do the same, but I'm going to get something called Entity Framework Core dot tools. Same sort of same principle. We're going to let that run. Okay, and then we're going to add the Entity Framework Core package dot in memory. We're going to add that to our test project. And let me go ahead and type this command, and I'll explain to you what that does. We're gonna add this to tests, csproj package, and then Microsoft Entity Core in memory version 9 star. So the reason we're adding this package to our test project is because we don't want to add, or we don't want to run these tests against our database. We want to, what we're going to be doing, in fact, is that we're going to be running the tests inside of an in-memory database. And the reason why we're doing this, first, even though this is a test application, this might not even be, this certainly would not be a production environment in which we're working. This could be a test environment. It might have a database already configured, but the point is that we want to use an in-memory database for performance purposes, because we, going out to the database can have some performance overhead. And even though we're just doing a single test, we we can just doing it in memory is just would just be more efficient for us. So we're gonna go ahead and add this package. Okay, so we're ready to move forward, and then we're going to add our test project to our solution project. So from there, we're going to say .NET add tests csproj reference, and then MVC movie csproj, and we're going to add that. Okay, it's been added to our project. Okay, so now there's some things that we want to confirm inside of our movie project. The first thing that we want to check is that we have this generate assembly info tag here inside of our property group. And the reason why we want to add this is because just in case we hit any duplicate assembly attribute errors, and that's something that can happen as we add different packages to our solution. So that just helps to avoid that error taking place. The next thing that we're going to do, the next thing that we're going to confirm inside of our MVC movie project is this. We're going to add a second item group tag, and let me just fix some of these. These are inside here. Okay, so I'm going to add some elements here inside this additional item group. So I'm going to add a series of files that I want to make sure that the web app does not compile when we build our solution. And these are generally going to be either inside of our test folder or in some of the hidden directories that we might see if we go to our File Explorer, but we'll see what they are in a moment. So we're going to add compile, remove, tests, star.cs. And then we're gonna close that tag. Then we're gonna add another tag, and this one we're gonna call this none, and then we're gonna say include. So basically we're saying to not include any from this path. Then we're gonna add two more, but these are gonna be inside the object directory, and then inside of the binary directory. Okay, so we confirm that. We confirm that our generate assembly info tag is set to false. And now we can go ahead and begin building our actual test. First of all, we're going to be relying on several libraries. We're going to use system, and we'll as we move forward, as we build out the project, we'll justify each of these. System, using system, threading, tasks, using Microsoft Entity Framework Core, and then we're gonna bring in the data, models, and services classes into our test. So we're gonna say there's gonna be three of them. We're gonna say using MVC movie dot, and we're gonna say data, models, and then services. The last thing we're going to add is our XUnit library. Okay, so we're ready to move forward. We have our movie service CRUD test class, and now we are going to first of all, we're going to be creating our constructor. So we're going to say private static movie service. So notice that this is of type movie service, and we're going to call this create service. And in this case, as I mentioned earlier, we are not going to be relying on the database for our project. We're going to be using an in-memory database. So we're going to say var options, and then new db context options builder, and then that is going to be of type MVC movie context. And then we are I think I want to do this sort of in parts. So I'm going to call this db context. Then for our in-memory database, I'm going to say in memdb, and this is going to be db context, and we're going to use the method use in memory database, and for this is going to refer to the movie object database, and let's give it actually we're going to give this a sort of identifier first. GUID, new GUID to string, and okay, let's see. Actually, one thing that I'm going to do, and it seems I might have I might have gone this route. I might have applied it to in terms of like the wrong scope. I'm going to add this package to the entire solution. So let's try that again. Let's run this. Okay, and then let's see. So let's rebuild. Okay, so it's there's been a bit of an improvement, but we're gonna address these as we move forward. So Let's finish. So our in-memory database method is available now. So let's just go ahead and finish up implementing this. So here, we're going to call this options. And then we're going to say in-mem-db options. Okay. And then from here, we're going to create something called, we're going to create the context. We're going to say context, and actually this would be the context builder. Okay, and then we're going to say new NBC movie context, and this is going to be have this object called options, and then we're going to return in this new object movie service context. Okay, so the next thing we're going to do is we're going to go ahead and build out our tasks, and at the end of that, hopefully, usually whenever you have some errors, either syntax errors or otherwise, usually fixing some of these issues will make them go away. So let's just approach these. Let's just build these out and see what happens. So we're going to say async, and this is going to be a task, and we're going to call this movie service, and let's call it can perform CRUD op or CRUD operation. Okay, so here we're gonna do several things. We're gonna have 4 operations, obviously: create, read, update, and delete. Okay, so let me just add some. I want to add some comments here. I'm gonna say we're gonna say create, read, update, and delete. And the first thing that I'm going to do is I'm going to actually create the service. I'm going to call this SVC, and I'm going to say create service. Next, I'm going to go ahead and I am going to build out my first test, and I'm going to call this var. I'm going to create an object called movie, and that's going to be using the movie class, and it's going to be new movie, and we're going to pass all of the different properties for this object, and I'm just trying to get it in a format that I like, and we're going to add the title. Let's just say Inception. Then we're going to say genre, sci-fi. Next, price. Let's say it is $18.99, and that's going to be currency. So we'll use the decimal suffix here. And then we're going to say, let's say for rating. I think it's PG-13. And then for the release date, that's going to be let's say date time parse. It's going to be a lot like our seed data class. And let's just say, okay, that it came out in, I think it came out in 2010. Let's say May 1st. Very good. So we created our movie, and now we are going to add that movie to our database. We're going to say await svc add async, which you'll remember is the command that we use for adding movies to our database. The next thing we're going to do is we're going to read from our database. We're going to get the ID from the movie, and we're going to say var saved, and this is basically going to check, this is basically going to return the movie by ID. We're going to say await svc get by ID async, and we're going to say movie dot. We're going to we're going to have the ID property. So even though, remember, if we go back to how we constructed this class, or the way that we have it is that the ID field gets generated automatically. So what we're gonna do here is we're gonna add some things called assertions. So through assertions, we are going to say that that some event, that something is true, and if it is not true, if we cannot assert that something is true, then that is going to cause our test to fail. This entire program is going to fail, which the goal is that it not fail, and through that we are able to test the different components that we add to our program. So we're going to say assert not null, and we're going to say assert equals, or rather equal, and we're going to check that inception, the word inception is, and we can go here, we can say movie title, and we're going to compare that to the title that we saved, right? So we have the movie that we saved, we have the movie that we originally created and added to the database. So we're asserting that these two are correct. Okay, the next thing we're going to say is we're going to update. We're going to update the value of our title from our saved object. So we're going to say saved title, and for here we're going to say inception 20th. Actually, I don't. Yes, let's just say it's 20th year anniversary edition, and then we're gonna update our entry. We're gonna say await svc update async, and we're gonna pass our saved movie. Then we're going to get that. We're gonna get the updated version, and we're going to say var. We should call this red, because that's kind of where we are. So for the read section, we're gonna save this to red, and then for our next one, we're gonna say updated. So this is our updated movie. So we're gonna say await svc get by ID async, and we're going to get the ID from our original movie. And let's call that red. And here we're going to do an assertion, and we want to check, first that updated is not null. I think that's a good idea. But then we also want to check that the updated title matches the movie title. Okay? We're there. So, and actually, for this one, we're gonna use the red one. Not the movie one, because the movie one has the old name. Okay, so after this, we are going to do our final test, and that here we're going to essentially be deleting the movie. I'm going to say await svc delete async, and we're going to pass movie ID. And we're going to get this object, which we're going to call deleted. Await service, get by ID. We're going to get the movie by its ID. And we're going to assert that it is null. And we're going to say assert null. And we're going to check that. Okay. So let's go ahead and deal with some of these errors. So I'm going to go here, and it's suggesting that I use a version of these packages that I need. So let's go ahead and use them. And okay, so these are okay. I'll use that one. Let's make sure that okay, let's see. Looks like it messed with our tag here. So let's just add it back. And I think I'm going to clean, and I'm going to let's see if I can rebuild. It looks like it rebuilt everything. We're going to go to our test, but it's having some issues finding these namespaces. And let's just go back to make sure that everything is correct. So let's delete all the content of our, or we're going to delete some of these files that we would be building, so we can then restore them. So we're going to say remove item, then recurse, enforce. We're going to say we're going to delete that binary folder, the object folder, the tests binary folder, and then the tests object folder. Okay, we're going to say .NET restore MVC movie project. Then we're gonna build it. Okay, that built successfully. Then we're gonna do the same. We're gonna restore and build our test project file, or rather our test project. We say .NET restore tests test.csproj. We're gonna do that. Okay, that ran successfully. Then we're going to say .NET build tests csproj. We're going to wait for that to finish. Okay, and that finished successfully. And after all of that, we can now run our test. So we're going to say .NET test, and then tests.csproj, and assuming everything worked correctly, and it says that our test ran successfully. This concludes my lecture. We discussed 8 architectural principles that will make our web applications more modular, stable, and testable, as well as extended the functionality of our application that we developed on session 1 through the use of dependency injection. As always, please reach out with any questions, comments, or concerns that you might have. Thank you for watching, and have a good day.